Welcome to the session for initializing the EPL and CAN networks for your ACR-EPL demo kit. First thing we need to do is connect to our 9040. This 9040 has been configured and tuned, so we don't have to go through any of those steps. What we're going to do is we're going to use some example code from our help files to initialize the EPL and CAN network. We're going to utilize a non-motion program, one of the programs numbered 8 to 15. And we'll also put a small program into program 0, one of the motion programs, to test our code. The first thing I need to do is make sure that I have some memory defined for my programs. So in the configuration wizard, I'm just going to go to the memory section and make sure I have memory set aside for program 8, which I do, and program 0, which I also have defined. So I can close this. I'm going to go to my program editor. I'm going to open program 8. Notice that each program starts with the word program and ends with an end P. Every program must start and end this way. The code that we put in will be going between those. We'll be replacing this little green message text here with our code. To get started and find the code that we need, we're going to open up the help file. We're going to go to the little blue eye up here for the user's guide. Once this is opened up, I'm going to go to the index. And the first thing I want to do is find my code for the EPL. So I'm going to type in EPL, and it says EPL network, so I'm going to select this. In the help file, we have routines already configured that you can use as a starting point for your code. So here's a section on initializing the EPL network. So I'm going to take this whole piece here, everything from the pound define, the program through the end program. I'm just going to take this and cut this whole piece out of the help file, or just copy it. We'll minimize that. I'm going to come back in here. Since I have program and end program as part of my text, I'm going to highlight everything in here and just do a paste. Now notice a pound define is defining a variable that's a local variable for this program, and it needs to be outside the word program. So the very first thing in here is a define for a variable called reset EPL network, and we're setting that to bit 150. Our program has a go sub, so that means that we have a subroutine in here which will start with an underscore. We go down through here, we find that underscore enable EPL network is our subroutine. Once the go sub has been executed, it will execute all of the code inside this subroutine. When it's done, it will come back up here and it finds an end. So at that point, it will stop. So with just this piece of code, we have our EPL set up to automatically initialize when this program runs. In order to get this program to run on boot, we need to use the pboot command. So that's used to trigger programs to run on boot up. So right after the program, the first line needs to be pboot. So I'm going to put in my pboot command. So when I power cycle the unit, the first thing it's going to run is this program. Since I have CANopen on this as well, I want this same program to initialize it as well. So I'm going to go back to my help file. This time I'm going to say CAN. So here's my CANopen. And to start the network, I'm going to scroll down through my help file and find the example code. So here's our example code. You notice in my example code, just like the EPL, I have a #define, which sets the reset CAN network bit. This also has a program, go sub, and end as part of its definition. So what I'm going to want to do is take the #define. I'm going to copy it, and I'm going to put that right after the #define I already have. I'll go back to my help file. I'm going to take my go sub, copy it, and put that after the go sub for the EPL network. So as soon as the EPL has initialized, it's going to execute the go sub for the enable CANopen. So I'm going to go ahead and make a comment here that says this is to enable my CANopen. So it's going to execute those and then end. So I need to go back and pick up my code now. So I don't need the program or the end. I've already got those things. So I just need the code. I'm going to grab everything from the _ CANopen down through the return and do a copy, which I'm doing a Control-C. I'm going to go back to the end of my program here. Now, this EPL code was set up to be run by itself. What I need to do is add a return command. So it returns back to the calling go sub. I'm going to paste my new subroutine. So once the first one is done, it's going to return back to the go sub. It's going to execute the next go sub, which sends me to the CANopen network. When it's done, it's going to return. Once both things have executed and successfully enabled, I want it to run my program 0. So it's going to transfer control from program 8 to program 0 and run whatever code I have there. So my next command is going to be a run prog 0 for program 0. So in my non-motion program, all this is doing is enabling my networks and testing to make sure that they're active. This command, the run prog 0, will transfer control to program 0, which is my motion program section. For my motion program, I'm going to set up a little looping program that I want to loop, say 5 times through. So to do that, I need a local variable. I'm going to do a dimension, long variable, and I only need one of those. I'm going to set my long variable equal to 0 to initialize. I'm going to turn on my drives. Both X and Y. Then I'm going to create a loop program. So I need an underscore loop or an underscore whatever name we'd like to give it. In my case, I'm just going to call it loop, which is the beginning of my subroutine. I'm going to take my long variable that I created, and I'm going to set it equal to itself plus 1. So each time I loop through the program, it's going to increment LV0 by 1 with a starting value of 0. I'm going to do simple relative moves. So for my first set of moves, I'm going to move both X and Y simultaneously. So I'm going to say X with a /, and I'm going to send it for a -10 revolutions, and Y for a -10 revolutions. Then I'm going to send them back in the positive direction for a relative move. Now, in order to make this loop a specific set of or number of times, I'm going to evaluate my LV0. So I'm going to say if, and for my evaluation, I need to put that in parentheses. If LV0 is less than 5, I want to go ahead and go to loop. Notice when I send it to my through to my loop, I don't say underscore loop, I just use the name. The underscore is actually telling it that that's the name I'm going to use. So the next thing is with any if statement, I need an end if to terminate the if statement. And for my program itself, I need to have the end P. So I've created a little motion program here, and we're going to save these things and download them to the processor. So I'm going to go ahead and just close these. I'm going to tell it to download my project. I'm going to go ahead and download everything. When you're just working with the programs, you can download just the program you're editing, but I want to make sure I have everything down. Now I want to make sure that my program's actually made it to the processor. I'm going to go to my terminal emulator. And it stopped at program 8. That's the last thing it downloaded. So I'm going to do a list. List will show me the program that's in here. Now notice I have the line numbers showing up. The reason the line numbers are showing up when I do a list is my processor has bit number 5651 turned on. If 5651 was turned off, CLR 5651, and I do a list, I don't get any line numbers. When we're debugging the programs, it's very useful to be able to see the line numbers, because if we have an error, it's going to come back and tell us what line it's on. So I'm going to go ahead and set 5651 back on. I'm going to go to program 0. I'm going to do a list of it. So things look good. It looks like everything made it down to the processor. Now, so I can see what's going on, I'm not going to reboot it initially to see if my programs work. I'm just going to go to program 8. So I'm going to go prog 8. I'm going to do an L run, a listen run. There are a couple of commands in there that have a print. As you can see right at the top here, it says print CANopen network problem occurred. There's another print that says it started. If I just tell it to run, I won't see those messages. But if I tell it to L run or listen run, I'll see the messages come up in my terminal emulator. So what I'm going to do is do an L run. Okay, I got my EPL network operational, but my CANopen did not start. So I probably have a problem in my program when I copied all of these things over. So I'm going to go back to my program 8. And we'll take a look and see where I might have left something out. We've got my defines, program, a pboot. We have the go subs. So we have our subroutines running. Does an end if, does a return. Comes to the CANopen. So we can see from my printf or my print statement here that I'm only printing out if the CANopen network problem occurs. So what I need to do here is add just another line similar to what we have for the EPL network that tells us that the EPL network is actually started. So in this case, we're going to say, we'll just take this code and we're going to just copy and paste that. And we're going to take out the not. And we're going to get rid of the rest of the CAN network. And in this case, we're going to say CANopen network, CANopen network, operational. Now, so when this bit is high, it is actually that the CANopen network has started successfully. So now I'm going to go back up and I'm going to download again. In this case, I'm only going to download program 8. Say OK. Downloads program 8. We'll say OK. We're going to go back to our terminal emulator. We'll do an L-run. So this time, it does show us that our network is operational and that our CAN network has started. I don't know if you could hear in the background, but my motion program was running. We'll do this again. L-run. So it makes 5 cycles, then stops. So now if I power cycle the system, that's what it's going to do each time. It's going to go out and it's going to check to see if the networks have started already. If they're not, they're going to do a reset and power up the networks, and then it'll come back with the network operational. In this case, we're just printing this information. In the case of your actual application, you could have it not start or not run program 1 or program 0 if they don't start. If you have an HMI attached, you could put messages up to the user that says that your EPL network is still down or the CANopen network is down. This particular code that's in the help file is designed to keep going through and trying to reset it. There's a lot of example code, and you'd use it just the way I've done. So I hope this has been of some use for you and has maybe made some things clearer. Remember that your non-motion programs, program 8 through 15, is where you do things like this. You're initializing things, setting things up, things that you only want to run once, or maybe things that they're not related to actual motion. You could put your error routines out here. Anything that has to do with motion, especially coordinated motion, needs to be in your programs 0 through 7. That's the end of this session. I hope it's been of some use. Thank you.